Hello friends, welcome to our channel where we are presenting mathematics lessons. So in this lesson, which is lesson number 3, we want to deal with 3 things. Number 1, how to find the radius of a small circle. Why talking about the radius of a small circle is simply because the radius of a bigger circle is already defined. Remember we said it is this 6370 kilometers, or if it is nautical miles, it is this value that has been given. So for the radius of a bigger circle, it's already approximated, it's already given, it's already known, sort of. So our interest is to find the radius of a small circle. What is a small circle? Remember we said all circles, I think lesson 1 or so, all circles of latitude apart from the equator are small circles. So like this one is a small circle, this is a small circle. So in this case we might want you to find the radius of this circle, mean that from here up somewhere here, what is the radius of this circle? Alright? Thereafter we'll ask you to find the circumference of the circle here. Okay? Denoted by small letter r, because capital letter R is for the radius of the earth or the equator. Okay? So our interest is to find the radius of a small circle from this point up to that point, for example. Alright? Thereafter you look at the distance of that circle. Okay? So we are saying for us to find the radius of a small circle, we'll use this approach. Of course, we are not interested in how to drive this. That's not our interest. So I say the radius of small circle is given by capital R cos x, where x is the angle of latitude. So if I want to find the radius of this circle, my x in this case will be 80 degrees. Alright? Then this R is already defined. That's the radius of the earth. Okay, so we're saying the radius of a small circle in this case, maybe for this one, will be capital R then cos x. Now, if you want to find the circumference, we know that if I could use this, that circumference is given by 2 we are saying circumference is given by 2 pi r, or we say by d. Okay? Now, because we know that this radius is this. Okay? So from here we can find the formula for the circumference of a small circle, which will be equal to, when you substitute, this is replaced by that, we have got this formula. So this one is the formula for the circumference of a small circle. So if you put this here, where there is r here, so you have c is equal to pi r. Alright? I'm getting this part now. This radius is this. So to be r cos what? Cos x. Okay? That is the radius. That is the circumference of a small circle. But for the circumference of the earth, of course, you can estimate by using this. Okay? Or you can get the final value, which is already known, in fact, because you can easily compute. Okay? So we are saying for a small circle, we want to ask you to find the radius of a small circle. Take note. Alright? And the circumference of a small circle. So we are saying for a small circle, this is the radius. For the circumference, that's what we are going to use. Take note, we are saying x is the latitude of the circle that you are dealing with. I hope that is clear. Okay? So that's how you are going to get the radius there. Either for this circle or that circle, the approach is the same. Okay? Now, if you want to find the distance that exists between 2 points that lie on the same circle of latitude, for example, x here and w, or y and z, we are saying find the distance of points along a circle of latitude. We are going to say the distance is defined by theta over 360 times 2 pi r cos x. Look, again, why are we talking about this? Because when we talk about distance, we are talking about an arc. Because if you have a circle, alright, if you have a circle, part of that distance is an arc. Now, in mensuration, if you're looking at the arc length. We normally say arc length is theta over 360 times 2 pi what? R. In this case, our 2 pi r is this one. This is the circumference. So you're going to say theta over 360 times this. Okay? That's where we are getting it from. I hope that is clear. Okay, so we are saying to find the distance of 2 points along a circle of latitude. Let's say this and that. You are going to say theta over 360 times 2 pi r cos x. Now, here you need to understand that this theta is called the angular difference or the difference in longitude. Since I'm dealing with the points that are on a circle of latitude, for example, W and what? X. It means that theta will be the angular difference here. Alright? Here. This angular difference that we have here is what we are calling the difference in longitude. So the difference in longitude of W and the X, that is our theta. Okay, so if you are dealing with this, so we are talking about the angular difference here. Okay? Here. That is our theta. Now take note that these are just representations. You can choose to use any other. You can even put alpha or what, doesn't matter. Okay? Those are representations. So we are saying the theta in this case, it is the difference in latitude between the points that we are dealing with. Okay? I'm sure here there was Y and here there was a Z. So take note. Now, so this is the difference in the longitudes, the two longitudes. Okay? Then, this is used when you are dealing with the distance in kilometers as well as the nautical miles. But if you're just interested in nautical miles, you can even go and apply this. At the end of it all, the answer will be the same. You can say theta, which still remains as your difference in longitudes or angular difference times 60 minutes times cos x. Again, there is a way of driving this which is not our interest. I hope I'm trying to make myself clear. So take note, if you want to find the distance between 2 points that lie on the same latitude, circle of latitude, you're going to say theta over 360 times 2 pi r cos x. Or if it is in the nautical miles, that is C measurement, you're going to say theta times 60 minutes times C cos x. Here I've even emphasized in nautical miles. Okay? So let's see the example here. Alright, I'll be able to solve it the other side. Roman number 1. Okay, so we are saying W, X, Y, and Z are 4 points on the surface of the Earth, as we are able to see like that. Alright? So you must know how to state the position. If you're looking at X, you start by stating the latitude followed by longitude. So you can say 80 degrees north, then comma 105 degrees east. You should know how to state the position. Okay, which is very important. Now, our interest is to first find the radius and the circumference, alright, of which circle? This circle. So we're saying, can you calculate the radius and circumference of a circle of latitude 80 degrees north? So we're interested with this, alright? We're interested on this, not this one, because our angle here is 80 degrees north, alright? So now, what we mean by radius here, we want you to find the distance from here, from the center here, up to somewhere here. What is this radius? All right, what is that? So we are saying, to find that, we are saying radius of a small circle is given by the radius of the earth times the cos of that latitude. Okay, so in this case we are going to say, what is our radius? The radius is usually defined or given. In this case, we've been told that we use 3437 nautical miles, or 3,437 nautical miles. So that's what we are going to put here. So we are going to say 37 nautical miles times cos latitude. Now, the cos here, so you say cos. What is our latitude? The latitude is this angle here, because I'm dealing with what? 80 degrees north. So you're going to say 80 degrees. Alright? I'm sure you're able to punch. Okay? With me, I've used this calculator. This is what I found. So you can also try to work it out. There's 596.8287 8664 That's what I've found. Okay, so you can you round off this to 3 significant figures in most cases, but that's what we are advised. So we are going to say 1, 2, 3. We cut there, or we chop a line there and consider the next number here. So if the number that is there is above 5, it's 1. Below 5 and above, it's 1. 4 and below, it's taken to be a 0. So in this case, we'll take 8 to be 1. Then we say 1 plus 6. So I have 7. So I have 5, 9, 7 nautical miles. Alright? Now take note. If we had 5, 9, 6, this. Maybe suppose we had this in nautical miles. Alright? Of course, maybe here there could be some numbers. How do you round it off? We are saying you say 1, 2, 3, you cut there and consider this, alright, as 1. So 1 plus that will be 7, so you have 5, 9, 7. Now, because you have a digit before a point, you add a 0. Why? Because there is one digit here. If there were 2, I would have added 2 zeros. So this one would have been your answer, alright? Take note with that, the rounding part, rounding off. In most cases, people tend to have challenges. Okay, so in this case, that is the radius of that circle. Alright? If I want to find the circumference, we are saying circumference, okay? Circumference is equal to 2 pi r cos x. If you want, you can just multiply this by 2 pi, or you can rewrite it. Alright, so that you don't have a problem. So circumference is equal to 2 times. What is our pi? Our pi has been given to be 3.142. That's what we are going to take. So 3.142 times our radius is 3437 nautical miles times, alright, cos. Here the cos, the angle here of latitude is 80 degrees. So we are going to write 80 degrees, alright? 1, 2, 3, 4. 1, 2, 3, 4. So we have plugged in all the entries or the numbers there. Okay, so you can work out that with your calculator, and I'm sure you will be able to find the 375.47209 525355. Alright, nautical miles. Okay, so you can round off that now to 3 significant figures. So you're going to say circumference is equal to 1, 2, 3. You chop here and consider this one. So 0 will be considered to be 0. So 0 plus 5, you get 5. So you have 3, 7, 5. Now because I have a digit here before a point, 1 digit, I'll add a 0. Now here, it's a bit confusing. Because there is 0, then we'll put a 0. Does not mean that if there is 1, you also put 1. No. If there was 1 here, Stumo would have put a 0 because there's a 1 digit before a decimal point. Alright? What I'm saying is if you have 3751.4, rounding it off to 3 significant figures would mean we were supposed to have this. Again, nautical miles. Doesn't matter the value that is there. Take note. Okay. So that is our the circumference, 3,750 nautical miles. What we mean by that is that the distance of this circle from this point, when you move or you were to measure, you'll get 3,750 nautical miles. But the distance from here up to there, you get 597 nautical miles. I hope that is okay. Alright, so for Roman numeral 2, allow me to erase. I hope we have been able to copy. Okay, so for Roman numeral 2, we want to find the distance between y and z. Alright? Now, you must realize that, you must know that y and z lie on a circle of latitude 30 degrees. They are on the same latitude. Alright? So how do we get that? We are going to say the distance between y and z is defined by the angular difference, or theta, times 2 pi r cos x, or you can say, because it is in nautical miles, you can say theta times 60 minutes by cos what? X. This is applied when we are dealing with nautical miles. Alright? If it was kilometers, we would have just gone for this approach. Okay? So now we are saying yz is equal to, what is our theta? We are saying if the 2 points lie on the same circle of latitude, alright, then the theta there is the angular difference here. Okay? Or the difference in longitude. So this is your theta here. That's what we want. Now, how do we find the difference in longitude between this and this? You look at the positions, where they are, alright, in terms of longitudes. So when you look at y is on the western part. Then z is on the eastern part. They are on different sides of the Greenwich meridian. So how do we find the difference in their longitudes? We find the difference by adding. So you're going to say 105, alright, plus, so you're going to say 105 plus 115, alright? You agree with me that this will be, this is what we are going to have. So the difference in longitudes is 120. So the angular difference is 120. The theta is 120. So you are going to say 120 over 360 times. Okay. Alright? Times by what? 2 by 3.142 times cos x. What is the angle of latitude here? It is 30 degrees. So you're going to say by 30 degrees. Alright? So yz. So I have to compute this one. So let me try to compute it. Okay, a colleague of mine is not there. The one who was helping me to do the computation. Okay. So you say 120 20 divided by 360. Alright? By 2 by 3.142. 3.142 by cos 30 degrees. Okay. Okay. Maybe you can just punch for me so that I write. So I'm trying to work it out. There's a colleague of mine who is helping with the punching because we're using a phone. But you can use a sand figure calculator. Okay. We are still waiting so that we get the okay. Okay, so according to what I found 1.8140345. So you can verify with your calculator. Okay. So why is it? Okay, why is it? Okay, take note here, we had left out the radius here. So we are supposed to indicate, even on your calculator there, whatever answer that you have found, you multiply by that radius. Okay, so the final answer would be 6234.83 67 33 89 and 33. Okay, this is the distance between the y and z in nautical miles. So we can round it off to 3 significant figures. So say 1, 2, 3. Cut the line and consider this number as 0 because it's less than 5. So 0 plus 3 is a 3. I've got 6, 2, 3. There's one digit before point, I'll add a 0. Alright? Nautical miles. This is the answer. Alright? Or remember we said alternatively you can say yz is equal to theta times 60 minutes times cos z. Alright? There is a way in which we can derive that, but that's not our interest. In this case, our theta remains the same to be 120, alright, degrees times 60 minutes times cos 30 degrees. So yz is equal to, okay, so we can try to compute. We are also trying to compute as well here. Okay, so when you work it out, you have got 6235 point 38 29 07 24 796. So yz is equal to, you round it off again to 3 significant figures. So I've got 1, 2, 3. Cut this one. Okay, so we have 6, 2, there's 4, 0 nautical miles. There is just a slight difference, just the rounding off part. But that's basically what you're supposed to do when getting these values. Okay. Okay, so here take note, it's supposed to be x. So the slight difference here is just the rounding of part. Okay, so in this presentation we are dealing with finding the radius, circumference, and the distance between 2 points along a circle of latitude. Okay, so we'll continue now looking at the distance between 2 points along a circle of longitude. That is our interest now. Okay. Okay, now so we proceed with the distance along a circle of longitude, like I mentioned earlier on. Okay, so now we are saying if I'm dealing with the 2 points that are on the same circle of longitude, maybe for argument's sake, W and what? And Y here. How do I get this distance? We are going to say theta over 360 times 2 pi r. Alright? Now, in this case, that theta is a difference in latitude between the points. So in this case, if I'm dealing with W and R, alright, then the difference in latitude between W and what? Or what we call the angular difference. So we are looking at an angle somewhere here. Okay? An angle somewhere here, which we are calling what? Theta. That's what we are supposed to get. Okay? Or if you're dealing with natural miles, you're going to say theta times 60 minutes there. It's one and the same. Okay? Let's take note. Okay, so that's what we are going to do. So in this case, if the radius given is in nautical miles, then the distance will be in nautical miles. If the radius given it is in kilometers, then the distance will be in kilometers. Okay, so now let's look at this question, which is the same like the first example, but the only difference is that we are dealing with the longitudes here. So we are saying calculate the distance between x and z. Okay? Calculate the distance between x and z. Where is x? This one. And z. So we see that x and z share the same longitude. How do we find their distance? One we are saying in nautical miles. So we are going to say here answers. Okay. So for A, we are saying the distance between x and z. So say x, z is equal to theta over 360 by 2 pi what? R. Okay, so now what is the difference in latitude between x and z? So you look at the latitude for x, 80 degrees north. The latitude for z is 30 degrees south. So they are on two different sides of the equator. So if they are on two different sides of the equator, you find the difference in latitudes by simply adding them. So you're going to say 80 plus this one, plus 30, right? And we get 110. So that is our difference in latitude between these. But if we were dealing with, for argument's sake, we had another circle here, alright? Maybe this could be M. And this latitude maybe is 45 degrees north. Okay? So how do you get the difference in latitude between x and m? If at all that was our interest to get the difference between x and m. So you get the difference here by saying 80 minus 45, because they are on the same side of the equator, on the northern part, or northern hemisphere. So you say this minus that. Is it okay? Okay? So but in this case, our interest is to get the distance between x and z. So we are going to say the angular difference, or difference in latitude is 110. So we have got 110 degrees over, or divided by 360 times 2 times, what is our pi? 3.142, right? By nautical miles. So we are going to use 34, 37 nautical miles. Okay, so xz is equal to, let me check what a friend of mine has found. Okay, so we have found that the answer here, when you compute, is 6599.421 88. Of course, there are a lot of numbers there, you can write all of them. Okay, so you round it off to 3 significant figures. You only do that if at all the question does not carry any instruction. So you're going to say 1, 2, 3. You cut there and consider 9. Consider 9 as 1. 1 plus that is 10. So you write, can't write the whole lot of 10. You just write 0 and take a 1. That 1 will be added to 5. So you've got 6. And this 6 here. But because after the 9 there's one digit here, I'll put a 0. So you have got that. Nautical miles. Alright? Alternatively, you can do your computation using this, because it's nautical miles. You say, what is my or we are saying hz is equal to theta times 60 minutes, right? What is my angular difference? What is the difference in latitude? We got 110. So you're going to say 110 degrees times 60. Alright? So when you do that, you can easily multiply these as zeros. This by that, so you have got 66. Alright? Then how many zeros? There are 2 zeros, so you put there. So you get nautical miles, if it is a nautical miles. Take note, this approach is only applicable when you're dealing with what? Nautical miles. I hope that is okay. Okay, so that is our answer. Then for kilometers, the approach is the same. The only difference is here, there. So for B now, for B, we are saying for us to find the distance that exists between X and Z in kilometers, the approach is the same. The only difference is the radius. So here, we'll put, instead of this, we are going to put now the radius that is in kilometers. So by, what is this radius? It is 6370 kilometers. So you have 6370 kilometers. Okay, so whatever answer you're going to get will be in kilometers. Okay, and my friend here has found 12231.1077777. There are a lot, you can write all of them. Then you round it off to 3 significant figures. If you're writing an exam under ICZ, that is the case. So you say 1, 2, 3, you cut down and consider this guy or this number as what? 0. Why? Because it's below 5. 0 plus this one, see, it's 2. Okay? So you have got 1, 2, 2. Okay? Now, because I've got 2 digits, okay? Okay, sorry for that. Because I've got 2 digits before the point, I'll add the 2 0. 1, 2 kilometers. That is how you find the distance. I hope it is clear. We've looked at how to find the radius of a small circle, how to find the circumference of a small circle, how to find the distance along a circle of latitude and a circle of what? Longitude. Is it okay? So I hope that is very clear. Okay. So I think we've tried our best to explain these things. So when you check in these papers, this is the exam papers, these questions are very, very common. Okay. So with me, I have questions that I would like you to answer. Okay. Can you answer them? I hope they are clear. can attempt this one. Just the part for, that is question 9A, Roman numeral 1 up to 3 only. Okay. I hope it is clear. Then I also have another one, question 8A, Roman numeral 1 and 2 only. Hope it is clear. Okay. You can also attempt this one. I hope they are clear. I hope they are clear.
Right, thank you very much.